I'm Michelle Mikes, the K-12 Mathematics Supervisor for the Cobb County School District. Our district is committed to helping students succeed, and you as parents are an integral part of this process. To help keep you informed about what your child is learning in our math classrooms, we are excited to provide you with these informational videos on concepts taught throughout the school year. Thank you for taking the time to discover ways to support your students' learning.
Welcome to the first grade Mathematics Unit 4 parent video. I'm Karen Harrison, a teacher at Nickajack Elementary in Smyrna. During this video, we will review the components of first grade Unit 4, Operations and Algebraic Thinking. First, we will focus on strategies to add and subtract within 20, including counting to add and subtract. First graders might begin to add by counting on entire sets of objects. From there, they begin to count on to add. Students can count one more to add one, or two more to add two. At times, they can also stretch that to count three more to add three. Let's add 13 and 1 using a number line to help count on one more. Students will learn through experience that counting on from the larger addend is more efficient. At first, students will use objects such as counting bears on the number line to model counting on. Placing the object on the number 13, they count up 1, which is 14, building the understanding that adding one more to 13 is equal to 14. Counting on 2 or 3 is similar to counting on 1. Let's add 3 and 15, continuing to use a number line to count on 3. Again, students will learn through experience that counting on from the larger addend is more efficient. Since 15 is the larger addend, students place their object on 15 to model counting on. Placing the object on the number line, they count up 3 times, 16, 17, 18. 3 plus 15 is equal to 18. First graders learn that counting backwards is a strategy for subtracting, equating each step back on the number line as taking away 1. Students can count back 1 to subtract 1, or 2 to subtract 2. Again, they can also stretch that to count back 3 to subtract 3. Subtracting 2 from 17 using a number line would look like this. Begin at 17, which is the total prior to taking away anything. Then count back 2, 16, 15, 17 minus 2 is equal to 15. Make 10 requires the understanding of decomposing one of the addends in order to make the anchor number 10 with the other addend. Here I've modeled 8 plus 5 using counters in a double 10 frame mat. 8 is the addend closest to 10, and I need 2 to put with that to make 10. If I could decompose or break apart the 5 into 2 and 3, I can put 2 with the 8 to make 10. Then, using understanding of place value, I know that 10 and 3 more is 13. I can record this numerically like this. 8 is the addend closest to 10. I know that I need 2 to put with the 8, so I'm going to decompose the 5 into 2 plus 3. Then I have 8 plus 2 plus 3. I'm going to add the 8 and 2 together, which gives me 10 plus 3. And again, I know that 10 and 3 more is 13. So that means that 8 plus 5 is equal to 13. Double facts occur when adding two addends that are the same number. These facts are typically committed to memory, although not a requirement to be memorized at this point. Using the counters in double 10 frame, I can model 1 plus 1, which is 2, 2 plus 2, which is 4, 3 plus 3, which is 6, 4 plus 4, which is 8, and 5 plus 5, which is 10, and so on. 6 plus 6 is a fact that most students can recall as being equal to 12. A near double, or double plus 1, is when the addends are only 1 away from each other. Knowing that 6 plus 6 is equal to 12, if I add 1 more, or 6 plus 7, the sum, I can reason, is 1 more than 12, or 13. Numerically, it looks like this. I have 6 and 7. I know that 7 is 6 plus 1. So my double fact is 6 plus 6, which is 12, plus 1 more, which is equal to 13. 6 plus 7 is equal to 13. Now we will look at the concept of adding numbers in any order. First graders work to build an understanding of two mathematic properties. The first is the commutative property of addition. It is important to note that students are not taught the term commutative property in first grade. That comes later. They do, however, learn the concept of the property and apply it when adding. Students can add 7 and 5 by building a model using colored counters on a work map. There are 7 red counters and 5 blue counters. Students might use the make 10 strategy when solving this problem. Using the counters could help to see 5 red and 5 blue, which makes 10. Then counting 2 more would be 11, 12. 7 and 5 is equal to 12. When the add-ins are swapped to 5 plus 7, students take the work mat and carefully spin it so that the counters and add-ins match. They can still see the 10 that can be made, and then count 2 more, 11, 12. 5 plus 7 is also equal to 12. By doing this, they have proved that the order when adding numbers does not affect the sum. The second mathematic property for which understanding is built is the associative property of addition. Again, the formal term is not taught or expected to be learned, but conceptual understanding is built. When adding 3 add-ins, students can choose which add-in to add or associate first. In adding 3 plus 7 plus 7, some students may choose to add the 3 and one of the 7s to make 10, and then add 7 more, which is equal to 17. Other students might choose to add or associate the doubles fact 7 plus 7 first, which is equal to 14, and then add 3 more, which is equal to 17. Changing the numbers that are added first does not affect the sum. 3 plus 7 is equal to 17, no matter the order in which the numbers are added. Next, we will look at the concept of using addition to solve subtraction problems. Students learn that a relationship exists between addition and subtraction. This relationship can be used to solve equations more efficiently as students learn to work with related facts. We view the numbers involved in addition and subtraction equations as either the whole or the part. When solving 15 minus 12, we know that 15 is the whole of the relationship and 12 is one of the parts. The part that we need to find, the difference, is also one of the parts. That means we can set up an addition equation with 12 as one of the add-ins, and when we add the other part, it will be equal to the whole, or 15. Starting at 12 on a number line, then counting up to 15, we see that the difference is 3 steps. That means that 3 is added to 12 to make 15, or that the difference between 15 and 12 is 3. Let's take a look at how students solve equations with missing numbers. When working with equations with missing numbers in different positions, students apply strategies they have learned along with the understanding of the relationship between addition and subtraction to solve for the missing number. Using a known doubles fact, students can add 6 and 6 to get 12. Seeing the sum on the left of the equation causes some students to think that it is written incorrectly. After they gain a better understanding of the equal sign, they learn that equations are correct as long as the two sides are balanced or equivalent. In other words, 12 is equal to 12. Seeing an add-in missing in the middle of an equation, students choose a strategy to use. What number can I add to 8 to make 13? Let's illustrate the make 10 strategy with a number line to solve for the missing number. Students learn that 8 and 2 are partners that make 10. Then adding 3 more would make 13. So I've traveled 2 and 3 on the number line. 2 and 3 is a total of 5. 5 was added to 8 to make 13. Now we will look at deciding if equations are true or false. When determining if equations are true or false, students need to take a look at both sides of the equation and determine if both sides are equal. The equation 7 is equal to 8 minus 1, which is purposefully written differently than what students might think of as normal, can be modeled using counters. We already know that the left side of the equation is 7. The right side is 8 minus 1. If we take 1 away from 8, 7 are left. 7 is the same as 7. So the equation 7 is equal to 8 minus 1 is true. A more complex equation, 9 plus 2 equals 2 plus 9, can be modeled with counters. Then counting on to solve. 9, 10, 11. 9 plus 2 is equal to 11. Students should notice that the add-ins are the same on both sides of the equation, just the order has been changed. The commutative property that we saw earlier in the video proves that both sides are equal to 11. Therefore, the equation 9 plus 2 equals 2 plus 9 is also true. When working with equations where different add-ins are on each side, students should solve the expression on each side of the equal sign to prove whether true or false. 5 plus 7 can be solved by making 10 and then counting 2 more to make 12. Students can manipulate the counters to model the double fact that is on the right side of the equation. The number of counters on the mat did not change, only the arrangement of the counters changed. Knowing that 6 plus 6 is equal to 12 means that the equation 5 plus 7 equals 6 plus 6 is true because 12 is equal to 12. With the statement 9 plus 2 equals 3 plus 9, there is a common add-in 9 on each side of the equal sign. Counting on 2 more from 9, we get 10, 11. We find that 9 plus 2 is equal to 11. Starting at 9 again, then counting on 3, 9, 10, 11, 12, we find that 3 plus 9 is equal to 12. 11 and 12 are not the same. Therefore, the statement 9 plus 2 equals 3 plus 9 is false because the sides are not equal. Finally, we will look at solving addition and subtraction word problems within 20 and adding 3 whole numbers to solve word problems. In previous unit videos, we have looked at how first graders work with addition and subtraction word problem situations, such as these, where the sum or difference is unknown, as well as addition problems where the sum is known, but both parts that are added together are unknown. During Unit 4, students work with addition and subtraction word problem situations where the change is unknown and where the start is unknown. The problem here is an example of addition with the change unknown. 5 ducks were swimming in the pond. Some more ducks swam to join them. Then there were 14 ducks in the pond. How many ducks swam to join them? Students would use manipulatives, draw pictures, and use their knowledge of addition and subtraction to solve how 5 plus the unknown number is equal to 14. Using the strategies they've worked on this year, students should solve that the missing add-in is 9 because adding 9 more to 5 would make 14. 9 ducks swam to join them. Rewording this problem gives an example of subtraction with the change unknown. Students would also use manipulatives, draw pictures, and use their knowledge of addition and subtraction to solve this problem. A concrete way to work out this problem would be to use a part-whole work mat and 2 color counters. To solve this type of situation, students would need to understand that 14 is the number of total ducks at the beginning, and that the total can be broken into 2 parts: the ducks that swim away and the ducks that are still in the pond. Understanding that if they take the part that they know from the total, which is the 5 ducks that are still in the pond, the other part will be the change that is missing, or the ducks that swam away, which would be 9. 9 ducks swam away. Addition and subtraction word problem situations where the start is unknown require a solid understanding of the relationship between addition and subtraction. This first problem is an example of addition with the start unknown. There were some children on the playground. 8 more children came out to play. Now there are 12 children on the playground. How many children were on the playground at first? Students would use manipulatives, draw pictures, and use their knowledge of addition and subtraction to solve the unknown number plus 8 is equal to 12. Using known strategies, students should solve that the missing addend is 4, because adding 4 to 8 would make 12. 4 children were on the playground at first. Rewording this problem gives an example of subtraction with the start unknown. There were some children on the playground. 8 of the children went inside. 4 of the children are still playing. How many children were on the playground at first? Students would use manipulatives, draw pictures, and use their knowledge of addition and subtraction to solve this problem. This problem can be worked out concretely using a part whole work mat and 2 color counters. To solve this type of situation, students would need to understand that the whole, which is the number of children who were playing on the playground at the beginning, is unknown. We do know the 2 parts, or the 2 groups of children. The 8 who went inside, and the 4 who stayed outside. Understanding that if they take the 2 groups and combine them, they can figure out the number of children who started out on the playground. The 8 who left and the 4 who stayed make 12. 12 children were playing on the playground at first. Another type of word problem included in Unit 4 gives situations where 3 addends are added together to find the solution. Students are expected to use strategies they have learned throughout the year, applying their knowledge that when numbers are added in any order, the solution will be the same. David gave his mom 7 pink flowers, 7 red flowers, and 3 yellow flowers. How many flowers did David give to his mom? Students should recognize that all 3 numbers in this type of problem are necessary to find the correct solution. A concrete representation students could use for this problem would be 10 frames with colored counters. Understanding that they need to add 7 plus 7 plus 3, some students may choose to use their knowledge of doubles facts and add 7 plus 7 first to make 14. Then add 3 more to make 17. Other students may choose to use their knowledge of combining numbers to make 10 and add 7 plus 3 first, which makes 10, and then add 7 more, which also makes 17. Either approach gives the same solution. David gave 17 flowers to his mom. This has been an overview for parents of first grade Unit 4, Operations and Algebraic Thinking. This video was created for parents with the purpose of providing clarification of first grade math standards covered during Unit 4.
Thank you for your time. We know that when families and schools work together, student success increases. Please visit the Cobb County Math Department website for additional information and resources to support your student at home.